Hi, and welcome to the fifth episode of Every Semicolon. I was trying to think of what to do. I wanted to make a short episode. I think the next gameplay mechanics thing will be to get on to making either these sort of custom blocks that require some more code, like the actual treasure chest, your goals, and that sort of thing. I think these sort of standard blocks for now are pretty much covered. But yeah, being able to actually start a game session and win it and that sort of thing is probably the next step. But I'm not going to do that this episode. This episode I'm just going to do something just a little bit random, a little bit different. Just do some more visual stuff. I want to make a short episode where I want to put some little bits of grass around, grass that will wave around. Ultimately, as I mentioned with the clouds, I think that I wanted to put some sort of wind system in later, probably to dictate which direction the clouds blow, and maybe that can also affect things like particles, and probably won't affect gameplay stuff. I don't think I really want to add that level of complexity to the game, and also big boulders aren't really going to be affected by the wind that much. Probably next episode I'll get on to doing something like just tweaking all the scale of everything. I think I was thinking about these platforms, and yeah, so this one is 100 by 100, which means let's double check that the rock platform, what scale have I got that? 1. So I mean, it's at a pretty standard scale. I can easily just manipulate that to whatever size I want, and there's nothing else here artwork wise, so I'll probably bring everything down to a smaller scale. And I think, yeah, just thinking about it, actually, if I'm building grass this episode, then I think it's going to be sort of obvious that scale is getting a bit of an issue, because a 1 by 1 meter, well, 1 meter is a bit big, so even a small bit of grass is going to be too hard to see. So I'll stick with the scale I've got for now, and make the grass larger than it should be, and then whenever it is next episode or whatever, when I change the scale of everything, I'll bring the grass down as well. So for grass, I want to use I'll probably just do like a hex sort of shape grass thing for now with planes. I don't want to use Unity's plane, as I talked about before. It's sort of I'm not really a big fan of their plane for that sort of thing, but I've got this this 1 by 1 meter plane here. I'll turn off the material generation and asset import and scale factor to 1. Apply that. If I drop this into here, okay, you can see that 1 by 1 meter is pretty tiny, so let's bump it up a bit, get rid of that rotation, puts Y to 2, and alright, that is going to be one of our grass planes. Can't see the back face at the moment. I'm going to turn off culling in the shader. Ultimately I'll probably just get a double-sided plane exported for this stuff, just to help with any sort of lighting issues that turning off the culling can cause. Okay, let's dupe that a couple of times. Just rotate these. Yeah, I'm gonna figure out exactly how I want to make this look later on, but whatever, that'll do for now. And let's make our shader. Make a material for him called grass. Grab something. Okay, and gonna need some sort of grass texture. Now I'll grab the Unity's terrain asset stuff. One of these, not that one. I'm not getting a preview of that one, but I think this is the one that I'll probably want to use for now. We'll get our own grass texture stuff going on, but I need something as a placeholder. There it is. It's a pretty cool little texture. As you can see, you can toggle previewing the color or the alpha, the texture, and you can see it's got an appropriate alpha map, so I can Okay, throw grass onto these planes. Just for now change it to a cutout diffuse, and you can see sort of what it will look like. A lot of people don't like cutout because of, you know, you don't get the soft sort of alpha blending. It's either on or off, but you know, there's massive benefits to doing so, in that you get, you know, it works sort of in the same way as regular opaque geometry, and you get shadows and custom received shadows and that sort of thing. And also writes to the depth map, which, you know, hence the shadows, but also other, if you're doing other effects with the depth map, then that's good. I mean, you can combine sort of cutout stuff and alpha blended stuff, but I mean, it's really not a big deal for something like this, I don't feel. And, you know, in most games you'll find we'll use this sort of cutout alpha test sort of shader for vegetation. Okay, shader time. We'll just call it grass. Alright, set it up as custom/grass, which is great. And what we're going to need is a vertex shader. So what I want the vertex shader to do is I want to look at, I want to manipulate only the upper sort of vertices of the plane. So I want it to wave around but not move at the bottom. So what I'm going to test first is just test whether or not the or test how I'm going to do that. So I wanted to get some sort of I think I still have the Unity CG.cg inc, which I showed how to get to before. It's in your Unity install directory. It's in CG includes folder. So app data full is the struct I'm going to use in for my shader here. And I'm going to output the input struct. So we're just going to test something first. I'm going to test the wave amount. So I could use the vertex position, the local vertex position, which in this case is going to be fine, but I'm also, you know, I'm not sure exactly how it's going to end up. I might want to just stick with using the UV mapping to determine how much to wave the grass around or wave the vertex around. Okay, so what I've done here is I've created a new float to be passed from the vertex shader to the pixel shader, fragment shader, and I passed in the as you can see here, text coord is the first text coord coming in, so that's your first sort of UV coordinates for that vertex. Grabbing the Y value of that, passing into this float, and then I've just taken out albedo for now. I'm just going to put straight emission in so that I don't have to deal with any lighting stuff, and to see what the value is. So let's come in here, go to our material. Nope. Okay, yeah, right. Let's delete that one. Okay, so the grass material, let's change its shader to the one we've just made, custom grass. And alright, that is entirely black. So what has gone wrong here? In.wave amount. So o.wave amount is v.vertex coord.y. It's a float. Yeah, data for v. Okay. So I'm not actually using this method. This method up here. It's we named anything. I've just named it vert because that's it's a typical one that I use. You actually have to tell the shader to use that as your vertex shader for the surface shader, or vertex function, vertex shader function. Okay. That's okay, I'm not gonna get tricked again. Fool me once, shame on. Fool me twice, can't get fooled again. Okay, so gamma space, that's okay, so I'm gonna remember 3.5 is gonna be a real nightmare for some people, I think, and for me so far it has been in shader development. I mean, that you can see there that's going from black to white in a linear fashion, but you put on linear, it's, I was looking at that and just thinking, what the hell has happened, you know? Is there some sort of thing to do with the scale? But no, it's fine. Alright, that was a close call. Okay, I don't want that. Put this back to this, and I don't need that to pass it the pixel shader. Instead, I want this to be just used here in the vertex shader. What I'm going to do is manipulate the vertex position. Let me just get started with something. Shader compilation can take a little while compared to script compilation, so that can be a bit frustrating sometimes. Jump into the reference manual, you'll see that down the bottom here we've got a bunch of shader related stuff. What I'm looking for is, yep, okay, Shader Lab built-in values. You have to include the cd.cg inc file to use these. A whole bunch of matrices here, which is good for, actually I probably will need to use something like that later. But what I'm interested in right now is just grabbing one of these. So they provide some handy little values here. This is a sine time, so sine of time, and they've got 4 versions of it. T divided by 8, 4, 2, and just regular t. So if I jump back into my shader here, if I do, we'll just do that one, should be a bit faster. Do that, come back in here, and wait and wait and wait, hit play. You can see that our plane shadows aren't updating. I think I know how to fix that. We'll get to that in a sec. They're just going crazy. They're going absolutely crazy. But you can see on there the x direction in their local space is going back and forward on a sine curve, sort of not exactly what we want, mainly because the bottom vertices are moving as well. So if we multiply that by wave amount, which the bottom, as we rendered that out before, if we saw that the bottom was black, the top was white, so wave amount for the bottom is black, which means it's 0, and we know that multiplying something by 0 is 0, so by adding that I get no movement, but on the top I get that x movement back and forward, which is pretty cool. Let's add in some z movement too. Should make a new it doesn't really, not a really big deal at all, I don't think, for this situation. Okay, I want to do a move amount equals fix 3. That, I want to move on the y. Let's use cos time. multiply all that by a wave amount. Do that up here. Oh, the good thing about shader stuff, even though it takes a little while to compile sometimes, you do not have to. You can recompile and it will change while the game is playing. So I'm only adding out to the X. I want to add that to the entire, well, not to the entire thing, because it's a float 4. So I want to do X, Y, Z. Add that. Okay, there we go. Now they're spinning around. Pretty cool. Let's jump in here and turn culling off. So that totally looks like grass. Video complete? No. Okay. I'm going to reduce the amount that these wave around. I might just chuck in. I'm going to change this, as I spoke about, change this later to use some sort of you know, global sort of wind vector and stuff like that. But for now, let's just throw in wind amount. I'll just leave it as a separate one for now. There's no reason I couldn't include just do it as a float 2 or a vector 2. Might also slow this one down. I should probably explain all this sort of stuff as a as an editor, as a property for the shader, but it's really just a quick demonstration, more so than wave amount should not be in there multiple times. It's more so than the final shader, which probably won't work on for a little while until I get to that stage of working on all that wind-based stuff together. Okay. So it should be less of a circular movement now and more just similar to what we saw before, but with the little bit of movement on the Z. Still pretty extreme, so let's bring it down. Now material. Okay. Not too bad, maybe a little bit slow. Somehow everything just fell over, so that's not good. Yeah, 0.2. Alright, gives a bit of movement. And because it's a material change, that persists once I stop playing. Alright, so the problem at the moment is each of these planes is moving independently of each other. We don't want that. That's not cool. If we go back to our ShaderLab built-in values, we have this matrix here, so world to object. What I want to do is multiply our move amount as if it was a world space vector, and convert it into the local object that we're rendering as space. So move amount equals mul world object, and I think world object is a 4x4. Probably make make this a float for fixed for it to work with, and then I just want the XYZ components. Should probably stop stopping it to let it play. Okay, so that's worked. We're now go to code, using that as a world space vector, and then putting it into the local space before we manipulate the vertices. So you can see they're all now moving together, starting to look a lot more like what we want. Now let's start doing the visual elements. So this is going to need to be alpha test. I want to give it a cutoff value. So in regular alpha test shaders, you'll find that they have this. Actually, I should probably, well, I won't show it, but I'll mention the fact that if you're trying to replicate, or trying to build a shader, and there's something in a built-in shader that you're trying to replicate, or figure out how they do, in the Unity on the Unity website, they have in the resources part of the site, you can actually download their built-in shader source, or you can just Google for Unity built-in shaders. You download that source, it'll have all the shaders that are built into Unity which aren't typically accessible, and that way it's a great way to learn and build shaders in Unity, because obviously they're usually built pretty well, written by the guys who know write all this stuff and know what they're doing. So if you're stuck or trying to figure out how to do something, that's a good place to look. This is the alpha cutoff. I'll do it. Yes, this is the way it's normally done in the Unity shaders. Which is cool. The range and 0.5. So what that means is anything below 0.5 alpha will be cut off as part of the alpha test. Okay, so now it's looking much more like our stuff from before, but we're getting shadows from the entire plane. So let's change the render type to transparent cutout. I should also change the Q to I believe it's alpha test. See if I can just do a quick check somewhere here. Alpha testing. Most of their example shaders unfortunately don't use, they're using this shader lab sort of code, which is not really used for more complex stuff. Typically if you're writing, when I'm writing my own stuff I don't use that, so it's not really that handy most of the time. Okay, I think I'm right. I'm not really too concerned. If it doesn't work, then we'll pursue it, but if it works, then that's fine. Bugger. Okay, render type equals transparent cutout, and Q equals alpha test. Yeah, okay. Don't have my quotes around Q. Alright. So that's back to resembling something that works. But you see this, I think I know what this is. It's this one I haven't really looked into the reasons why, but it's puzzling to me what the go is here. So, alright, transparent, cut out, vertex lit. Alright, the fallback shader seems to often impact the visuals of the shader. So if I change that You see that the shadows are now gone just by changing what the fallback shader is. So that's quite strange. We're in forward rendering mode, which means, well, it's a directional light, that shouldn't matter. But I think, yeah, so what I was mentioning previously about updating those shadows, I think if you add shadow is what we want for having the shadows update based on after the vertices are moved around. So that's working quite nicely. Okay, I mean, yeah, this three-plane solution works great from distances, and you can move all around it, and it's not billboarded, so you don't get that weird effect of things rotating around. So yeah, little I don't know if this will come through in the video, but if I can get it to be fairly prominent. Getting this sort of 1 pixel line here at the top, that's a bit annoying. If I change it to clamp, that gets rid of that. Apply that. Okay. Texture wrap modes essentially mean if your coordinates go beyond 0 and 1, it determines whether or not it wraps around and reads the texture again or not. Okay, that's waving grass. Shadows are working. Self-shadowing is working, and yeah, I mean, that's quite a nice little effect there. So let's stop that for a sec. Our shader is pretty much done. Let's grab. It's a bit strange. They look like they're on an angle. Huh. I guess that means the cos time value in the editor is not 0, which is a bit strange. I guess no, that makes sense. It is cos and okay, 0 cos, but it'd be nice in some way that didn't happen. But I guess that does still make sense. But all right. Anyway, waving grass. Do we have a? We don't. Let's environment prefabs. Make a folder for detail objects, and we'll drop the waving grass in there. Now let's just put in. She's still doing that. Let's put in a temporary game object for. Oops, for grass. Probably write a little system later on for, or maybe even I might just continue this episode for a little bit longer and do something, but just for placing grass randomly around in an area. Wow, I hit some buttons that I don't know what I just did. Wow, okay, how do I kill that? Whoop. Interesting. Now I can do cool stuff next time I do a video and draw on the screen. Alright. Yeah. It's very dark, which is not really what we want. Why is it so dark? Is that the actual texture color? I mean, it's probably not dark typically. It's just compared to this like extremely bright green surface here. Yeah, it does look dark. So let's go into the shader and see if we can do something to pump that up for a bit. We need to put some property in to determine how much we want to make this go crazy. Multiplying by itself, not a good idea. get it really bright for a bit. See how that looks. Yeah, so we're going to need our own texture that matches more closely the colours and the style that we're going with. You can see that's toppling. We'll see if we can get in there quick. No, no, not going to happen. Not going to happen. I can still contribute to the destruction though. Oh, that one is near death. Wonder if we can finish it off. Oh, so glad I got this on video. Okay. Waving grass. Pretty cool. We're going to have little dudes running around. The grass is not going to be that big relative to everything else. You know, this is just so I can see it. Getting lots of aliasing on there, so depending on how close we end up getting to this stuff, it also will be on this platform, and the camera gets in probably fairly close at times. And so another thing with the approach we've taken, let's see how it looks from up above. I mean, that's not too bad considering the camera is so far away, because it is doing that movement on both the X and Z axes. It's always sort of not pointing directly up, so you still can see it from this perspective. So that's okay. I think that's alright. That's that hexagonal. We might even be able to go to a just two-plane setup or something, or do some lotted versions and have billboards in the distance or something like that. That seems to work fine. I think this, it's not not a slow shader really. Anyway, that vertex. If I was doing this on the CPU, in a script, moving these verts around, that would be a lot slower, a lot slower. So that's not too bad like that. Let's make a little script for building detail objects quickly. I don't want to do random detail objects. I don't want to be random every time you play a level. I'd rather just be able to place them and then shift them around and get them looking right. Because I probably have other stuff possibly on these islands too, maybe little trees or rocks and that sort of thing, and I just want a quick way of populating it with grass. Yeah, now I think about it, yeah, I can do it. Alright, yeah, let's just do it. It's not going to take too long. I don't want this video to be long. I want it to be, I was thinking half an hour, which I've just crossed, but maybe if I can just quickly write the script, we can just sort of sum all this up. Alright, so I want to edit the script for object placement, mass object instantiate. Alright, might not talk too much for a little bit while I just try to quickly make this window. A private variable to store the object we want to make. Might make this be able to take multiple objects later and instead of just one. In fact, I'll do that right now. I'm not sure if object field works with the rays, so I'm just going to test it out first. Okay, it seems like it does not. Don't have I normally like to make a utility method for resizing arrays. Might do that now. Something I'm not. I don't do this tons in C#, so I'm gonna just see what happens. T. See what sort of errors I get. D cannot be found. It's a generic method, say. Apologize in advance for making this method without knowing exactly how to write a generic method off the top of my head. I mean, I have done it before. Let me include generic, that might help. Resize array T. Make it a ref. Yeah, we're getting closer. Don't want to return. Okay. That was fun. Right, so let's see if I can make that an array. or if it will just okay, yeah, okay, that might work. That might work. Alright, let's try that. See, I don't mind figuring things out and learning things on video at the moment. If it's something like this, you know, I just haven't written tons of generic methods in C#. You know, I've template stuff in C++, yeah, but less so of this sort of thing. But you know, that makes sense now that I think that should work. So let's have a look. What I want to do is make a new array of that type at the size we want, and then copy across any of the contents of the existing array into that one, and then make the well, I'll probably do it in yeah, okay, let's do that. So let's just try that first. T new array equals new T size of array size, make that the length. Array.copy array 0 to new array 0 array size, and I need that if let's just see, mathf dot whichever one is the max, or the in array dot equals array. Oops, array equals new array. Alright, so we'll test if this works in a sec, but the idea is that I make a new array with the length that we desire, and then copy across the contents from the original array into the new array. If the new array is larger, then the existing array can only copy across what it had in it previously, and if, which say the minimum value of those two will be this one, and then if the new array is smaller, then we only want to copy that across that amount in. So that should work, and then we set the old array, the reference array, to the new array. So if the length differs, prefabs equals u dot resize array. Oh, I don't want to do that. Prefabs. Ref prefabs. I'll probably change it from a reference to something else later, but if I can just get that working, that'd be sweet. I need to put ref in there. I need to put ref in there, no. Num prefabs. Resize array. Okay, yep. Silly. Game object. This one, game object. Get one. It's missing ref modifier. I do need to put ref in there. It's silly. Again. Okay. And we'll see if this one works in a minute by just changing it back and forth. Prefabs I. It's obsolete. I need to tell it whether or not it can use scene objects. Okay, so it's not showing. Create the right side of window again. Here we go. 5, 3, 6. Alright, so that seems to be... Whoa, doesn't like me hitting that lots. Fair enough, 4,000 or whatever I hit things is a lot for it to render. That was probably a pretty stupid thing to do. Alright, luckily didn't have to shut anything down. I might put some sort of max in there. And it might be worth putting all this stuff in a scroll window, or a scroll region. Around this. GUI layout dot begin scroll view. That's my scroll position. It returns the new scroll position. And edit GUI layout dot end scroll view. Now mass object instantiate now. If I make 50, you can see here I've got this scroll bar in which to populate them with. Anyway, I'm only going to want to do one, so that was a bit of a waste of time, but I'll probably use this later on for detail object placement. Okay, let's make a method in here. I'll just do it straight in here for now, just to get it working. I need to give it a transform and range. So, okay. Probably, there are definitely better ways to do this, and I'll probably change what I'm doing later. Just want to get this script working. So I've got some questions. Don't have the name right now to attribute it. Tony the Demon. I was asking if it's hard to script for shaders. So he saw me writing shader stuff before, and that didn't go too badly, which it often can. Distance from center to max distance from center point. Yeah, I mean, it can often go much worse than it did, and it depends on what you're trying to do. If you're trying to create something new that hasn't been done before, I mean, obviously that's a lot of trial and error and stuffing around, and often a lot of maths, and but it's it totally depends on what you're trying to do and your experience. I mean, doing stuff for the first time is difficult. You just gotta pick an amount to spawn as well. Really, the best way to learn is just by doing. It could take a while to get to the point where you can make anything that you think is worthwhile. But your best course of action is to find something that you need to make for your game, or something that will look really cool, and something that hasn't been done before. And if you can figure out how to do it, then that's a big step. There's another infield. What I'm going to do is make a list of actually the quickest way for now to get this done will be to no, let's just stick with the list. 3 spawn positions. This is going to be, I'm going to do this not well. I'm going to randomly pick a position within that's radius, and I'm going to just hard code some stuff just because I want this video to end within the hour. So all I'm going to do is make sure it doesn't spawn things too close together, but I'm only going to just test that for a little bit, and then instead of, okay, here we go. I'll just write the code and we'll see what happens. Okay, so we're going to pick a position. Fortunately, I have a on unit circle. That would be cool. So obviously this needs more stuff to determine whether or not you want it to be in block one of the axes or something like that. But I'm just going to hard code it to always be spawned on the same Y position as the center point. Rectin. That's strange. I want to check if say spawn positions. I'm going to hard code the distance, minimum allowable distance for now as well. One meter. Okay, and this can get into an infinite loop if I made that number too high, so I'll put in a maximum number of checks it can do. This isn't the best way of doing things necessarily, but it's gonna do for now. Okay. And then we want to add our new position to spawn at, and actually do the instantiation. I believe that Unity provides a editor instantiate method. So prefab utility instantiate prefabs what we want to use. So let's have a look here. Again, no C# example. Right. Yep. Nothing too out of the ordinary there. So what this does here, the random range, if you give it an integer, unless they've changed it, the max value is exclusive. So you can just pass in the length of an array like that, and it won't use the if the array is 3 and you know the length is 3, has 3 values and the length will be 3. If you try to get the third value from that array, you'll get a array out of index. But because 3 will be excluded, the max number is excluded, it'll only do 0, 1 and 2, which is what you want. So that's pretty handy. Okay. I expect that to fail miserably once we get the thing compiling. Get position, blah blah. Need to give it the center point dot position and what would we call that? Yeah, radius. Also, for you want to add stuff like telling it to parent everything I instantiate to a certain object, so chucking grass, for example, and make that happen. So this platform is the center point. So 1 prefab. I should probably default that to 1 as well. So go back to the script, let's change that default value there to 1. Find our prefab. Systems number of objects to create. Let's make that something less is 20. Oh, yeah, 50 is fine. Hit instantiate, and what did we end up with? We ended up with 1. No, we ended up with 50 in the same position. Did everyone else notice that I didn't actually set the position of this object, because that would have been too clever. I also need to put stuff in there like, whether or not to rotate the object and all that sort of stuff as well. So I'll just leave it. Actually, I'll give it a random rotation just because I know that's what I want to do. The standard instantiate methods for runtime usage allow you to put the position and rotation inside the instantiate call, but instantiate prefab does not. Let's just rotate. Okay. Like 30 meters was a little bit too far, but seems to work fairly well. Let's give it that transformed parent too. Okay. I need to do that. And let's just increase this to 200, distance 25. Okay. Made the mistake of doing a square instead of a circle, so that's not going to fly. Let's put that maximum minimum distance in there too. Save there. Hold on, let's just put some default value in that's going to work for this grass. Now it's going with 4, which means that it's sort of a 2 meter radius. So if I make it 5, then it gives a 1 meter buffer between them. Okay. Parents say okay. I might just use the unit sphere because just to show how it works, because it's pretty cool. Just generates a is it a method? No, just keep writing. Generates a random value on a unit sphere, so I can multiply that by the radius. So it goes from 0 a vector sort of 0 to 1. It's only on unit sphere, not in unit sphere. Maybe they have a oh wow, okay, I totally wasn't thinking before. That is exactly what I want. So multiply that by radius. So it returns a vector 2, so vector 2, random circle point, what's that? Center point plus new vector 3, x, 0, and y. Let's get back to a bit higher, 28, instantiate. Alright, so that seems to have worked pretty well. See there's a bunch of sort of empty patches here. I think we'll find that to be having less if I increase this check number. I don't want to increase it too high and make this drag on forever, but let's just give it a go anyway. Alright, so you see the patches are not as large now. So what happens is it finds a random position, and if that position is close to another blade of grass, another object that's been instantiated, then it will look for another position, and it'll do that 50 times and then give up. So we've still got some empty patches. I think theoretically I can increase this maybe one more time. Yeah, I think we're just not instantiating enough stuff. Alright, that is pretty dense. Whip over there. You can see all those blades of grass moving together in the wind. Looks pretty cool. All casting their shadows and casting shadows onto each other. Theoretically, yep, sure are. And still seems to be running pretty well. It's 50 frames per second, so down from lots. But if we turned off all but 20 or so, see the frame rate will be dropping fairly substantially as we go, but I don't think we'll need too many in the end. Once they blend a bit more into the terrain and have more objects around, I think that sort of number will be good. Be more patches around a particular area with rocks and stuff, and they want to be out of the way of the characters we have in there and things like that. So, and probably I think the island's also maybe a bit smaller compared to the weapon will take up more space. So anyway, that's still pretty cool. Pretty happy with that. And I think that's a pretty good video, just a little bit over an hour. That shows how to make waving sort of grass and do vertex shader stuff. Some more shader stuff is always fun to do, and also another editor window, pretty handy one actually. It's one that you can use project to project and build upon, and obviously find lots of uses for it. I can chuck a game object in here just wherever, and do a quick test of waving grass and cloud and a catapult. It is running, I'm not sure if that's going to affect anything. Let's drop that there. And you can compare it to this as well. Max distance from center. Let's make that 50 meters. Let's create 25 things. Instantiate. And you see we've got 25 objects with the you know, randomly waving grass, clouds or catapults created from around that point, the random rotation. So that's pretty cool. Alright, that will do it for this video. I'll probably use this to make more clouds in the environment later on, once I've maybe updated the script a bit more. And so I'll get on to placing grass properly once I scale these things to their more appropriate sizes. Alright, so I don't know when episode 6 will be, but probably not too long. I am pretty keen to keep going with this stuff, so thanks for watching, and yeah, just comment, let me know questions, anything like that. Like Tony the Demon. Alright.